Okay, so this is question number 8 of the section B, and it has a maximum mark of the 15 points. And as you can see, this is a geometric sequence question. So means this is topic 1. Okay, and also this is finance question. So question A, we need to find the total amount Daniela would receive if she chooses the option A and option B. So let's discuss this option A and option B. So there are information given regarding these options. So Daniela and Sorin have each recently received some money, and Daniela won a cash prize. Sorin received an inheritance, and Daniela had 2 options to choose from to receive her winnings. In both opinions, she receives a payment on the first day of each month for 3 years. And that means, the 2 options are the option A and B. In both options, she receives a payment on the first day of each month for 3 years. Okay. So option A, each payment is $5,500. Option B, the first payment is $2,000. In each month which follows, the payment is 6% more than the previous month. Question A, we need to find the total amount Daniela would receive if she chooses the option A and option B. Okay, so let's try this question on a new page. So let's start with the option A. So Daniela receives I'm going to write option A first. Okay, so for the option A, Daniela receives the $5,500 per month, right? Per month, and then for 3 years. So we can do times 12 months per year times 3 years. Then we can calculate the total amount that Daniela would receive for 3 years. So this is same as this. Okay, you can just use calculator to calculate it. II, which is the option B, because she's receiving the first payment as $2,000, right? The first payment is $2,000, right? And in each month which follows, the payment is 6% more than the previous month. That means this is a geometric sequence. So what we need to use is we actually have to use the sum of the geometric sequence from your, like the formula of the sum of geometric sequence from your formula booklet. The sum of geometric sequence, the formula is same as Sn equals U1 times r to the power of n minus 1 over r minus 1. Okay, and we know that the r, the rate, right, is same as 1.06 because we are gaining the interest. So we go S n value, which is equal to 36, right? The how many times she's getting the payment, right? The n is the number of the payment. So S36 is same as the first initial payment, 2,000 times 1.06 to the power of 36 minus 1 over 1.06 minus 1. Then you can calculate her total payment for 3 years, which is this. Okay. Then question B. We need to write down the expression for value of the Sorin's investment after n years. So let's look at this information. There's extra information. So Sorin received an inheritance of the $1,200,000, and the Sorin invested his inheritance in an account that pays a nominal annual interest rate of 4% per annum and compounded monthly. Okay, and the interest is added on the last day of each month. Okay, so 4% per annum compounded monthly. That's the part that you need to remember. Okay, so question B, we know that this is finance question and we have to use the future value equals present value times 1 plus r over 100k to power over k times n formula from your formula booklet, and the r is again the means interest, right? We know this. And then the n means number of the years or payments, right? And then k is same as number of compound period per year, right? That's what we know. So let's try to set the equation. So we are trying to calculate the future value, which is the Sorin's investment over n years, and the present value is same as $1,200,000, right? And we know that the R, which is the interest, is same as 4 over 100, okay, 4% times 12, right? And to the power of 2 times n, okay? So this is the formula they're looking for. So let's try the question C. Okay, question C has 2 baby questions and there are extra information that we have to consider. Okay, so Daniela chooses the option B and received her first payment on 1st January of the 2023, and Sorin invested his inheritance on the same day. CI, we need to find the total value of the Daniela's winnings and Sorin's investment on the last day of the 6 months. Okay, so CI, okay, so Daniela's winning can be calculated using this formula, right? Which is from the previous question. And using calculator, we can calculate it as the $13,950. Then we can calculate the Sorin's investment as, using the formula from the previous question, as this, okay? And you guys must be thinking, how did I calculate the 6, right? 6, it has been calculated as a 12 times 1 over 2, and that's the reason why it's equals to 6, okay? Then we have to add these two together. Then we end up getting the total value as this, okay? Then let's look at the CII. We need to find the minimum number of the complete months before the total value of the Daniela's winning and Sorin's investment is at least $250,000, okay? So for the CII, we know that the minimum, the number of the complete months is same as, to calculate the minimum number of the complete months, we have to set the inequality equation, okay? So we're going to go 1,200, 1,000 times 1 plus 4 over 100 times 12 to power of n plus, this is the equation that we have set in from the previous question, right? So I don't have to explain it again. And has to be greater than or equal to 257,000, right? And then we're going to use the GDC to calculate this equation. Means we're going to set or substitute the first equation as our y1, on your calculator, and second equation as our y2 on your calculator. Okay, and then we just have to calculate the intercept of these two graphs. Then the intercept value is intercept value, you are definitely going to get intercept value, but what we are looking for in that value is the x value. Okay, so we're going to look for the x value of the intercept. Then we get 27. So we can say that the x value or the minimum number of the complete months is approximately 27. Then let's look at the question D. We need to find the value of the R if this investment grows to $53,000 after 6 years. And we have extra information. At the end of the 3 years, Daniela invested $40,000 for the future 6 years in a second account that pays a nominal interest rate of the R% per annum compounded quarterly, right? So in order to solve this question, we're going to use that future value, present value formula again. Okay, we already used it in the previous question. So we're going to go future value equals present value times 1 plus r over 100 times k to the power of k times n. We're going to use this formula again, and we're going to substitute all the information that we know. Okay, the future value is $53,000, right? And present value is $40,000 plus 1 plus the R value is unknown. That's what we need to calculate. And K value is 4 to the power of 4 times 6, right? And we know that we can rearrange this equation. So we're going to go 53,000 over 40,000 equals 1 plus R over 400 to the power of 4 times 6. Okay, now since we know we can use GDC, again we're going to put the left hand side of the equation as y1 on your GDC, and the right hand side of the equation as y2 on your GDC, and again solve for the intercept. Okay, and we are looking for the x value of the intercept. Okay, then you will get the R value equals to 4.71781. So you can say that, or the x value as the 4.71781, and we know that the x value is actually same as R value. We can say that, finally can say that the R value is same as 4.72, and we have to calculate our answer.